Nice to meet you, everyone. So, as I was gently introduced, I'm JB. So this talk is going to focus on pentesting and how we can bridge it with observability and performance monitoring, which is not like an obvious topic, but we'll see we can do fun things with that. Just a word about me. So I'm working as an AppSec engineer at Datadog. I was CTO and co-founder at Screen, so we built application security from within applications. We got acquired by Datadog in 2021. Previously, I worked at Apple in the red team, and even before I was a pen tester. You can find me on Twitter or via email. Really open to questions, but we'll have some time for that in the end. And we have a booth, Datadog booth, right there, so feel free to step by and say hi to me or to the team. So first question, what is performance monitoring? Sounds like a silly question, right? Pretty obvious, but actually, is it the right question? No. The real question is what is observability, right? So performance monitoring is one part of observability. That's the art or science to understand when you are running a production, when you have servers, when you have services talking together. It's the art to understand how the system is behaving. Is it going well? Is it feeling unwell? Do you have bugs? Do we have good performance? Are the customers happy? If we have a bug, how can we troubleshoot it? That's what performance monitoring and observability is about. So it has little to do with security, right? You might say availability is a part of security. You would be right. So yes, a little bit. But beside that, traditionally, not so much. But things are changing. We, as an industry, as researchers, as practitioners, are starting to understand that there is a bridge to be done between observability and security. And so this bridge is starting to become a reality in a lot of defensive applications. And now I'm going to talk about how we can apply it to offensive applications. So why do engineering teams care about observability? As I said, it's very important to understand the health of your system and the behavior of your systems. So let's assume you are a DevOps in a company. You are running, maybe operating maybe 30, 50 applications or microservices, or maybe serverless functions. You arrived maybe a year ago, so you know a big part of it, but you don't know all of it. Obviously, you didn't write all the code. You don't know all the databases or third-party tools that those things are using, right? So when you are a system engineer, the complexity of the thing you're dealing with is insane. And it's very hard to grasp because you didn't build it, and you have a team of engineers who are changing it every so often, right? Like they deploy every hour. They are using Terraform to change stuff on the cloud you don't even know. My God, it's a mess. But how do you are still responsible for the things to behave well, right? So you need tools to help you visualize, understand how things are talking to each other, how to debug it, to monitor the deviations of the system. And so on the right, you have a small picture. I didn't find the attribution of that one, so I'm sorry for the author. But yes, load balancers, ingress, queue proxy, service mesh, sidecar, and in the end, application. Those are a lot of layers, right? That's a lot of opportunities for something to go wrong as well. And so when you attack a complex systems, because that's why I'm here today, it's to talk about offensive stuff. When you attack complex systems, well, a lot of the needs that you have are similar to the one that engineers, DevOps, SRE have, right? You want to understand the system to accelerate your recon. You would like to have facts instead of hypotheses. Why am I getting a 500 when I'm putting a quote here or an internal IP? Well, those are a lot of questions that it's hard to understand. It's hard to get a clear answer to, obviously, and that's the job of pen testers. So you would love to be able to observe the response of internal systems when you run stimuli on them, right? Maybe discover hidden components. Who in the room is doing pen testing? Okay, a fraction of us. Good. Who already dealt with pen testers? Who already received a pen test report? All right, all right, all right. So you will know what I'm talking about. So how could we do this, right? And get answers to all the questions that are burning when we are trying to attack a system. So the question is not how do we do this as security practitioners. The question I want to answer first is how do product engineers do this? Product engineer meaning the team that is making the system alive, making your production alive, ensuring that your services and applications and APIs are behaving well. So the focus of the talk is around modern observability products, right? So usually we distinguish two things. But another way to put it is that they give you full stack visibility. So full stack is a big word, right? It's a bit almost gross to say it. You have that all over on LinkedIn, Twitter. Any recruiter is looking for a full stack developer. So it's not what I mean here. What I mean full stack is from the kernel level up to the API behavior, right? Everything that is happening within your infrastructure, from the cloud provider to the application itself. And those observability tools, they can give you a vision around all of that. And that's very important because when you want to make sure that a system is alive, you want to know about the container orchestrator, how it's configured and how is it performant, the host and container applications, the data stores, and what we call the cloud control plane. How is your cloud configured with users, with security settings, with system configuration. So you have many paths to get there, all right? So you have many products, whether they are open source or commercial. And here I want to do a small disclaimer. I work at Datadog, but I will use Datadog as an example a lot because that's the one I know best. But you have all of those products and platforms that allow you to do something very similar. So whenever you hear Datadog, you can replace it in your mind with any of those other things, and that works in the same way, all right? Who already used one of the products listed here? Okay, quite a bit of you. Who already used one of those products in a security context? Okay, good, quite a bit. Who already used any of these products in an offensive security context? Whoa, 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 I have 2 here, 3 here. Is that it? 4? Higher, if I didn't count you yet. Okay, please come and we'll have a chat after. Okay, not right now, not right, stay seated. Okay, amazing. So among that, you have some that are open source, that you can set up yourself. I think we might be missing Elastic, I think, which is open source as well. But bon, that's the idea. I'm not saying this is exhaustive. So let's take a quick look at what actually is an observability product. Right, so this is Datadog. Disclaimer, you can do similar things with a lot of other products, right? So here we have all of our hosts sorted by availability zone. We can see that some are misbehaving, right? We can see hosts, we can see information about the networks on each of these hosts when we have matching results, which is the demo effect, of course. You can get information about the processes that are running within that host. And so that's kind of things you need when you want to investigate why something is going wrong with your production. So that's really interesting if you are an ops or an SRE or a DevOps to get this level of information. If you are a developer, but also if you are an ops, you might want to go at a higher level and understand what services are running on those hosts, what APIs are running on those hosts. So thanks to observability products, you can get this information because the observability product will understand how services are talking together, what kind of databases they are relying on to, what kind of requests they are receiving, and you can deep dive on many of the full stack layers of your organization and of your production system. So thanks to that, developers can really deep dive and see, okay, I have a trace, so I can see how the request flew from end to end on a given service. I can relate that to the infrastructure. And really, thanks to observability products, you get all of the context of your production systems. So that sounds amazing, very interesting. You can even go beyond because, for instance, you have logs, right? So you can look at what your systems are doing from a login standpoint. But if we have all of this information, why aren't we using it from a security standpoint? If you are familiar with, I don't know, SOC analysts who are reading alerts from SIEM hours per day, if they had everything at their fingertip like that, wouldn't that accelerate them? If we were able with, instead of using like raw HTTP traffic to correlate attacks with runtime information, couldn't we accelerate things? That's the idea. And that's what I want to show you. It's how we will do that from an offensive standpoint. So let's focus on distributed tracing. You've seen the huge service map where I can tell you which service is talking to what database, what cache, what other services. And so the question is, okay, how does distributed tracing work? So let's assume that A, B, C, D are services. One of them, B, is using Redis. The goal is to reconstruct the map that you have on the right. So you know how performant they are, how much time was spent in each service. So with that visibility, you know that if, for instance, C is starting to have performance issues, you can easily pinpoint the issue because you have the performance of each of the service. So how does that work in practice? Let's assume that you have a customer request that is entering your system. Okay? In each of the applications, so A, B, C, D is each an application, you have what we call a library. Okay? The library will look into the incoming requests. If they see a trace ID, they will propagate it to the subsequent libraries, right? So let's assume that we have a trace ID that is X. Initially, the library and the service A didn't see any trace ID, so it generates a random one and propagates it everywhere. The next thing that happens is that this is centralized to an observability product, and the observability product is able to reconstruct a trace. Okay, so really the graph of how, or the tree of how the services are communicating together. So APM is magic? No. It feels magic. The first time I installed an APM on an application I was developing and I saw details about the request, the database queries, performance, information about the other hosts that my code was fetching, it felt incredible. But obviously, it's not magic. You have some limitations. For instance, if the communication between B and C is not done with HTTP, but with something else, well, the APM need to understand that something else, so it can propagate the trace ID into that. If it's not able to do it, well, you will lose the information. And so you will get like a broken trace within your dashboards. And obviously, recording all of the traces has a cost. So you need some sampling. So you will not be able to gather 100% of the traffic. Okay, those are kind of the limitation of those tools. And I'm not even talking about deployment, because if you want to get started with an APM in a large company, well, you need to convince developers to install a new library on all of their applications. So more and more often, developers are requesting these kind of things because since the systems are more and more distributed, they make it, those tools makes it much more easier to visualize and debug and understand. So now, we want to pen test with observability. Are you starting to see where I'm going here? The goal is to turn Burp Suite into an APM library. So who already used Burp Suite here? Okay. Who has no idea what Burp Suite is? No shame, no shame. But I don't see much people raising their hands. Last chance. Who has no idea what is Burp Suite? Okay, good. So just in a word, if you are pen testing an application, well, you want to be able to use your browser to use the app because, I don't know, React, Angular, you cannot like simulate a browser. It's very hard. So you use a browser to interact with the app, and Burp will act as a relay between your browser and the application that you are pen testing. So it will intercept all the API calls. It will show them to you. And I think actually I have a, yes. And it will intercept all the APIs call, show the API calls to you. You will be able to inspect them, modify them, replay them. And so that's how you can inspect the request and the response of the application. So that's a very useful tool in order to understand actually what you are doing during a pen test. So what I built is a very simple Burp extension that is actually using APM mechanisms in order to inject a trace ID within any of the requests that Burp is receiving. And so that trace ID, if you are pen testing an application that is using one of those observability products, will be propagated everywhere. And so later you can find it back in that product. That means that when you are doing a test, you can leverage all the information from the observability vendor. So it means that as an offensive engineer, you will get all of this information. So who can use this? Obviously, you need to have a system. So you know what? Maybe we can talk about who can use this after. So let me live redo my slides. You don't see that often, right? Me neither. Oh no! It was full screen. I'm sorry. Can someone sing a song while I'm doing that? Thank you so much. All right. So let's take a real use case and let's investigate how this could help us with, for instance, a SQL injection. So what I have is a vulnerable web application here. Okay, it's WebGoat. It's the OWASP Java 1, super standard. What I did is that my Firefox is configured to use Burp. Okay, so the reverse proxy we discussed previously. Here I have Burp, who is using the APM to Burp extension, which is open sourced, and I shared the link after in the slides. And so while we are using Burp in a service, in a proxy mode, all the requests are intercepted, and if we move to the edited request, we can see that we injected a trace ID. Okay? So the idea is that you can very easily use the extension to open the trace ID in the APM. Takes a bit of time to load because I'm in 4J and I'm not on the right organization, so I will just need to change it right here. Demo effect second time, I'm sorry. Tac, tac. Ta-da! Here, we have the details about the request that was found into Burp, okay? So this one is a random one. It's not super interesting. Now let's focus on trying to do like a SQL injection, okay? So since we are all advanced security experts in the room, who is not? Kidding. Don't answer. I don't want to know. We can just try this. So this one, okay. Goal, can you log in as Tom? Straightforward, it's a typical SQL injection, right? So not super funny. I'm gonna do something like that. Okay, space, login. Oh, didn't work. All right. So maybe I'm gonna try quote and quote to see if any bug is triggered. Nothing. Okay. So here, I don't understand. It's not straightforward to do to fill that challenge. So I'm looking at my trace. Those are the quotes that I injected, and I'm gonna open it. Guess where? In an observability product. Here I am. I can go to the span list, which has all the information about that request. Is it big enough? I'm gonna zoom in a bit. Is it better? Oh yes, thank you. And so we can see, okay, a lot of SQL queries that we don't care about, but this one seems to be the one we try to inject. And we can see that like it doesn't seem that the injection worked. So let's get back to it. And actually we have a register tab, so maybe here I will have more luck. Let's try, register now. Oh, I need a valid email address. Yes, that's my real one. Register, oh, okay, something went wrong. So this time we can investigate again. So I'm gonna use that one, and again, open it in the APM. All right, so I'm gonna get back to the span list. And what do I see? Oh, here, what do we have? User ID equal question mark, so it's plain select, but I have an error. So in one click, I'm able to see the exception generated within the application by my request. How amazing is that? How would that make pen testing easier if we had access to exceptions? A lot. So very, very simply, I can get all of that information. Since I've got the shape of the SQL query that is used by the application, I can really deep dive, and as I'm forging my actual attack, I can understand how the application is changing things. And already that, having the shape of the SQL query will help me a lot. So that's trying to find the slides. That's how we can go further with SQL injection. So to help like the errors and the shape of the SQL query that we have. And you can think that's the same for any database that is supported by the observability platform that you are using for a MongoDB injection, for a Cassandra or DynamoDB or whatever. Any kind of injectable query language will be displayed in those observability vendors, provided they support the thing. So SQL injection is cool, but can we do something else? SSRF, server-side request forgery. Who has no clue what SSRF is? Don't be shy. Oh, come on, what are you doing here? I'm kidding. Okay, so SSRF is when you have an application that takes as input a URL, maybe because the application offers to configure a webhook, or maybe because the application allows to fetch a URL, an archive, or I don't know what. If the URL is not validated properly, or if the application isn't secured against SSRF, because that can open a lot of debates, the attacker can put private IP address within the application, right? And so instead of fetching something innocent remotely, the application might fetch something on localhost, something on the cloud provider's infra, something on, I don't know, the administrative interface of your web application firewall. So it's an attack where an attacker will perform malicious, unattended actions within your network thanks to mis-sanitized URL field. So good thing we have, we have a server-side request for jury attack in this challenge. So let's try that. I think this one, yeah, okay. So we need to steal the cheese. Extremely fun fact. I'm a French guy, but I don't eat cheese. Still, I'm gonna demo that to you. I know. How heroic. So here we can see that we have a URL, okay, images tom.png. Let's try with a random URL and see if something works or not. So I need to go in intercept mode. That's a burp demo as well. I will replay the thing. This one I drop. WebSocket, I don't care. Okay. There, I have it. Okay. So let's try to replace that with a URL. And what could we do? Like put invalid IP address. That should trigger an error, at least, right? We can forward. Up. And I will remove the interception. And so what happened? Okay, so you need to stick to the game plan. So apparently it didn't work. I can go into the HTTP history. I will find my SSRF query. We can see that it's the injected one. And okay, so I have no sign of an error or anything. What am I gonna do? Open that in an observability platform, of course. I open in APM. And so what we can see is nothing. No error. Okay, we can look at the span list. There is nothing that looks like an HTTP request. Okay? So it's just an SSRF that is only doing internal local file queries. We got hinted by the shape of the initial argument, but here very easily we can tell, okay, there is no need into trying to exploit that in this way. You cannot reach external servers with that feature, since the application is not even doing an HTTP query. Interesting, right? So we win hours of work by looking at the thing rather than looking at the trying to guess and by trial and error. What you could even do and go beyond is look at the network. So I have no network data because I'm on macOS, but if you are using that on your Linux systems, you would be able to see the shape of the network. So you would be able to tell whether you are within AWS VPC, whether IMDS v2 is configured or not, and how you can exploit actually this SSRF. So this is what we can tell from that. And we can even have code insights, going beyond what the APM library instruments explicitly. Here you can get information about anything. So the way it works is that most of the time, since observability products are used by teams that need to have performance insight, you will have features that allow to get very, very precise performance insight about your systems. And here we have the profiling. So a profile is a sample that is took every so often, like every 50 or 10 milliseconds. It takes all the stack traces of the processes that are running, and it will format it to you. So here, the stack traces taken are the one of your web app or API. So we can open it, And we can see the profile for that specific service. And we have no profiles found, which is, again, the demo effect. So I'm going to get back to my other, to my demo organization. Yes. There. So since it's statistical, it might be that we didn't use the app enough. Obviously, it's an app that I'm running locally. I didn't do a lot of requests on it, so it's very possible that the profiler was blind to it. I can open a given service. Let's assume that's the one we want to, we are currently attacking. And so I get a lot of information about the performance, but that's not really what I'm interested about. What I'm interested about is all those low-level information about what code is actually running and what the app is actually doing. If I scroll up, I can even sort this information by library. Okay, so I get information about all of the libraries that are running on that platform. How useful is that? Let's assume that you have a hint and you want to exploit a given CVE on one application. Well, if you want to know if the library, the vulnerable library, is actually running or not, you can use such a tool to get this information. And very easily, you can even pick your target and choose amongst all the APIs you have at your disposal, which one is actually running the vulnerable version of the service. I'm sure it happened to you all the time, trying to exploit, I don't know, Log4Shell or any kind of Tomcat CVE or whatever, and not finding the right target for that. So again, with leveraging all the tools that developers, ops, SRE are using, we can get very, very important insights that are useful from an offensive security standpoint. There. So that's interesting, but who can use this? Obviously, you cannot use that in a random pen test because you need to have access to the observability platform in order to get those insights, right? But that's extremely useful for red teams that are testing internal systems. If your company is using an observability product, then very easily you can get an access legally, ask your team, and use it as a source of information for all of your tests. So leverage those internal tools. You can also discover blind spots, right? Because you can know what is not monitored within a company. If it's not on that tool, most likely people don't really know about it or don't have alerting on it. So those are systems that you can use to build persistence. That's not so nice, but red teamers are not nice. I know, I was one. It's also useful if you are doing like open box testing with customers, right? With access to the source code, with meetings where people explain you their systems, etc. So if that's the case, you should ask to your customers access to those tools. If you are performing pen tests for your company, offer your pen testers to use those tools because that will accelerate them a lot. There is always a time when you sit with them in a room and you explain them what you have, and that's painful. I remember as a pen tester, this time it's often very hard to understand complex systems. If you are looking at something visual where you have actually names and something you can relate to, that will accelerate the communication with the pen testers a lot. And obviously, if you are doing closed box testing, well, you can still access to such an observability product, maybe, by doing recognition on Stack Overflow. You can find the ops or the dev of a company, maybe looking on GitHub, and you can still access to their observability platform. So if you manage to do that, that means that you have a lot of information about the system. It's almost as if you were an insider to the company. So I think that's often under-rated way to access systems, but I'm guessing we will see more and more things about that in the future. So I've talked of the present, right? And I gave you 3 examples of what we can do with those systems, but this space is moving super fast because you know we have more and more of code everywhere. Software is eating the world. Performance and reliability and quality is more and more important for all of us. So those systems are evolving in terms of quality a lot. So what I think we're going to be able to do in the future that will even accelerate security teams is, for instance, we've seen profiles. You've seen like raw functions. In that, we will be able to link them to URL, to path, to routes, to SQL queries. So you will have a matching between what external system and application is doing down to the line of code that is actually performing those queries. You will also get information about vulnerable libraries, right? You saw we can already access the libraries. Well, knowing which vulnerability is running where, when, and on what traces, it's already, I think a few vendors are already doing it. It's like super close. Vulnerability detection. We have tools that are using, for instance, source code, not source code, but runtime insights in order to build vulnerability detection. Those things could come within those products because that's, again, something that is useful for developers and that will also be extremely useful for security teams. And last but not least, the source code integration, because yes, if you can access the source code of those things, that means you can very easily pinpoint a commit to a given vulnerability, for instance, but also if you have a behavior that you cannot explain as a tester, then using the source code will help you dive deeper and get the full understanding of what the application is doing. I mentioned about open source alternatives, so you have all of that. I didn't use most of them. I'm familiar with them a bit, but those are things you can look at if you want to get started with open source. This is it. If you have any questions, I'll take it. Otherwise, you have this QR code with all the resources and links of that presentation, the source code for the Burp extension, link to Datadog, which has a free trial if you want to test it. And not a detail, we are hiring. We have an office in Lisbon, Paris, New York, Madrid, and we take remote job offers. We have a booth just right there. Feel free to jump in and say hi. Any questions, Tim?
Any questions? No questions. Thank you so much for your presentation.
Thank you. If anyone who... Thank you so much. So feel free to meet me at the Datadog booth for a chat. And the few people who did offensive plus observability product, I'm very interested to talk to you right now.